Alrighty, today we're going to be talking about lesson 5.4, which is the fundamental theorem of algebra. All right, there is quite a bit of here, so I'm going to take each theorem and I'm going to kind of break it down into in what I would say easier to understand language, and then we will then apply it with math as well, just like we've done every single time. So here we go. So the first thing we'll look at is the actual fundamental theorem of algebra. And basically what it states is if some function, we'll call it p of x, is a polynomial function, then there is at least one zero. There could be more, but there's at least one zero, which is like a solution. And it basically could be real or non-real. Right. And basically what that means is solutions and zeros and roots and all those things are where it crosses the x-axis. So for real, if we saw it cross the x-axis, there's our real solutions. But if we never see it cross the x-axis, then those are going to be your non-real solutions. Is there still a zero? It's just a complex imaginary answer, but still a solution in its own right. So there will be at least one solution as long as it's a polynomial, because for a polynomial, it starts off with a linear function, which has at least one answer, which has one answer, which falls in the family of polynomial functions. So that's basically what the fundamental theorem of algebra is stating. If p of x is a polynomial function, there's at least one zero, and it could be real or non-real or both. All right. The next theorem it talks about is the linear factors theorem. All right, and this is basically just stating if there is a polynomial function named p of x, and it can be written as a polynomial function of this form. And this is basically just a fancy way of saying, hey, this is standard form. All right, this is basically like a coefficient with the highest degree. Another coefficient doesn't mean it has to go down by one. It could be the same number, but it's just a coefficient that is connected to the next exponent that's one less. Even if it was a zero, then these could all be zeros and same kind of concept. All right, so again, this is basically standard form when we write it from highest degree to lowest. And then, so if it can be written like this, then it could be written in factor form, which basically is p of x, a leading coefficient, so a of n, times x minus some zero times x minus some other zero, dot, 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 times x minus all the zeros. So basically, if I have 15 zeros, I can write it as x minus those all 15 numbers as x minus 1, x minus 2, x minus 3, whatever the answer is, but it can be written out there. And if I was to distribute it all out, I would get to the conclusion of standard form. So that's what we're going to be kind of doing today. The next one is interpreting the linear factors theorem. So if we interpret this right here, basically what it's stating is that for a nth term polynomial, so or nth degree, I should say, polynomial. So meaning if it is a highest degree of 7 or 20 or whatever the concept might be, there will be, so an nth degree polynomial will have at most n x-intercepts, also known as solutions, zeros, roots. So basically, if I have x to the 7th, then I'll have at most 7 unique answers, or I could have one unique and one answer. It won't be unique, but it could be like, but I would get that answer 7 times. So I'm going to have 7 answers at the most, and then some might repeat, so I might have less. So that's why it says at most. So I have that amount or less, pretty much. So that's the interpretation here. Then I kind of highlighted this in the last section, but I guess I got ahead of myself. But this kind of goes more into detail of the multiplicity of zeros. And I'll kind of explain it like I did in the last video, but we'll have more illustration in your textbook on this. But if, and again, multiplicity just means how many times you get the solution. Meaning if I get a even, so mainly meaning if I get, let's say, x minus 2 twice, I can write it to the second power. Or maybe I get x minus 2 3 times. I would have that answered 3 different times. But if it is a even amount, graphically, it will touch the x-axis. It won't go through it, but it'll touch it and bounce back. If it is a odd amount of times I would get that answer, so like if it's just 1 time or 3 times or 5 times, which is typically your norm, graphically, it will go through the x-axis at that solution. So if the answer is 2 and I got it 2 times, it'll bounce off 2. If I got 2 as an answer and I got it 3 times or just 1 time, I'll go through the answer of 2. All right. So that's basically what multiplicity is. We kind of talked about it in the previous section, but now the textbook gives it more of a definition. So that's basically what they're trying to say. There is one more theorem, and it's called the conjugate root theorem. And again, the book goes into a lot of detail, but I'm just going to try to tell you basically what it is. If A plus BI is a solution, man, my pen keeps going out, then A minus BI is also a solution. And if you don't know, this right here is actually the conjugate of A plus BI. And remember, this right here is a complex number. So this is a complex number written as A plus BI. And if I tell you this is a solution, then you will automatically know that the conjugate of it is also the solution. So then with that, I can then write it as a factor. So if A plus BI is a solution, then X minus A plus BI and X minus A minus BI are factors of the polynomial. And again, that is basically what it's trying to explain to you in those theorems. I always find that theorems aren't written for best understanding. All right. So with that all said, let's do some examples to make this make more sense mathematically. All right. So I'm going to look at first question number 1. It says sketch the graph of each factorial, but we'll also look for certain things to help us graph it. I think on your homework, not all of them ask you to graph it, but it asks you to look for things. So I want to make sure we hit all those things. So one of the things are, let's make sure we know how to find the y-intercept. What is the degree of the polynomial function? What are the x-intercepts? And then out of those x-intercepts, which ones will bounce off and which ones will go through? Not using the multiplicity. And then, of course, just knowing how to graph. And again, it kind of gives you points and kind of guidance for that. So on number 1, it says f of x is equal to x plus 1 to the 4th power, x minus 2 to the 3rd power, times x minus 1. And what we're going to do with this, we'll start off by finding the degree. So I think that's always the easiest thing. So the degree, we're just going to add the exponent. So this would be x to the 4th, so that's 4. This is x to the 3rd, so that's 3. This is just x, so that's going to be 4 plus 3 plus 1. So again, that's 4 plus 3 plus 1. So that means that my degree here would be 8. All right. So then now that I got the degree, let's look at y-intercepts, which again, I find that to be the next easiest because we know x would equal 0. So here, if I'm looking for the y-intercepts, I'm going to plug in 0 for all of these functions. So this right here would just become 1 to the 4th, negative 2 to the 3rd. Oh, not plus. I don't know where the plus sign even came from. Hold on. Times negative 2 to the 3rd times negative 1. So this will give you 1, 2, 4, 8, negative 8, and then negative 1. So that gives you positive 8. So our y-intercept, I think once it has a coordinate on your homework, will be written as 0, 8. Next thing we're going to do is find x-intercepts, which are just as easy. When it's in this form, you just take each one of those factors and you set them equal to 0. So x plus 1 equals 0, x minus 2 equals 0, x minus 1 equals 0. So this gives you x equals negative 1, x equals 2, x equals 1. I'm going to add in multiplicity, which is how many times I would get the answer. This one, I would get the answer 4 times. This one, I would get the answer 3 times. This one, I would get the answer 1 time. So now that you have all these x-intercepts, that basically will come out to, negative 1, 0, 2, 0, and 1, 0. If you want to know if it bounces or goes through it, you would basically say, all right, any even numbers would bounce. So the negative 1, 0 would bounce. And then the x equals 2 and x equals 1 would go through. The x-axis basically is what's going through. So it'd be bounce, through, respectively. All right. And then we could use all that to help us sketch a graph. So here we go. We'll just sketch it. We'll start off with our y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. So something right there. Let me do a different color. And then our x-intercepts, we got negative 1 right there. We got 2 right there, and we got 1 right here. Because the degree is 8 and the leading coefficient is positive, positive, positive. So this will be a even positive. That means that it would look something like this. So I would start here, stop here. So now I know at negative 1, I would bounce. So I would go to it, bounce off. At some point, I have to go through the y-intercept. I don't know how high I go after that. And then I would go through the 1. At some point, come back up, go through the 2, and then finish up like that. So this is what the graph would roughly look like. And then from there, again, we'll figure out at what point these values actually hit their max and min at a later date. All right, so let's definitely try some more examples. Let's look at number 4. So this is g of x equals x plus 2, x minus 1 cubed. Again, looking at the degree, I can see this is going to be 1 plus 3, so the degree is 4. This is a positive, positive. So I know it's going to be even positive for the leading coefficient. I don't think it asked that, but that kind of helps us know how the graph is going to look. So we'll start here and stop there. The next question was y-intercept. So that's g of 0 would be 0 plus 2, 0 minus 1. So let's give you 2 times negative 1 cubed, which will give you 2 times negative 1, which will give you negative 2. So the coordinate would be 0, negative 2. Then the next question was x-intercepts. So again, I set each one of those equal to 0. So that's going to be x plus 2 equals 0, x minus 1 equals 0. So I get x equals negative 2, x equals 1. Then the coordinate would be negative 2 comma 0, and the coordinate would be 1 comma 0. Using this multiplicity, I get the answer 1 time, and I get this answer 3 times. And since they're both on, they would both go through the x-axis. All right, then take all those facts and we can sketch a graph. So I'll start off with that y-intercept. Then I do my x-intercepts. And since I know it's even positive, I know it's going to do something like this. And so now we got to go through. So I know I'm going to go through this first x-intercept, sometime bounce back up, and I would go like this. All right, so roughly it looks like this. Technically, there could be some more loops up here. We don't know that quite yet. So yeah, just kind of keep that in mind. All right. And now we're just sketching it. So here's number 6. G of x equals x plus 1 squared times x minus 3 cubed. So again, degree would be 2 plus 3, which is 5. Both positive, so I have odd and positive, which roughly looks like this. Nope, I lied. Looks like this. And so therefore, then the y-intercepts is g of 0. That gives you 0 plus 1 squared, 0 minus 3 cubed. So I get 1 squared times negative 3 cubed. So that gives me 1 times 3, 9, 27 will be negative 27, which will give me negative 27. So my coordinate here is 0, negative 27. Probably not going to graph that. And then my x-intercepts would be x equals, oh, I guess I should write it all out. X plus 1 equals 0, x minus 3 equals 0. So I get x equals negative 1, x equals 3. So my coordinates negative 1, 0, and 3 comma 0. Then I'll do my multiplicity. How many times did I get the answer? I got this one twice, and I got this one 3 times. This one's even, so that means it will bounce. I say bounce because I think that's what it says in your book as well, instead of touches, but same concept. And then this will go through. All right, so here I'm going to graph it. I know I start somewhere down here. I know I finish somewhere up here. I know I have one at 2, do a different color. And I also have one, oh, no, I lied. I have one at 3 and another one at negative 1. All right, so I know it bounces here and goes through this one. I know this is how it ends. The y-intercept, somewhere way down there. We'll pretend that's negative 27. So I'll start here. When I get to negative 1, I know I bounce off of it. So I'll kind of touch it, bounce off at some point, go way down here, come through back up to 3 at some point, and then finish off like that. There you go. So hopefully that gives you a better understanding. So let's kind of move into the next type of questions you'll get. It says on the number 10 here, it says use all available methods to factor each of the following polynomials completely and then sketch the graph of each. So here we go. So we got P of X equals 2x cubed minus x squared minus 8x minus 5. So we want to factor this so that we can analyze and get all of our stuff like the y-intercept, x-intercept, things like that, so that we can sketch the graph. So find y-intercepts are super easy. It's just this answer, but x-intercepts not so easy because you have to solve it. There is a couple of processes that you could try to do. If it's 4 terms, you could try to factor a 4-term polynomial in which you would see what the greatest common factor is out of the first 2 terms and the last 2 terms. And if you get the exact same factors back out, then you can keep it going. I can just kind of look at this and know I'm not going to get to that point. So what we have to do is do what we did in the previous sections. I need to look at my P divided by Q for possible zeros. So I'm going to do all my factors of my constant term. So that's 1 and 5. All the factors of my leading coefficients. That's 1 and 2. And then I get plus or minus 1, plus or minus 5, plus or minus 1/2, plus or minus 5/2. So there's all my possible zeros. So then I need to do synthetic division to try to figure out which one of these give me my answer. And remember, we're trying to get so that the remainder is 0. All right, so as always, I'll try 1. And then that would give me x cubed is 2, x squared is -1, x is -8, and my constant's -5. Again, you don't have to write this. I just kind of want to explain where all the numbers are coming from. Drop down that first number. 1 times 2 is 2. Then add -1 plus 2 is 1. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. And then I get -12. Not yet. So I'll try -1 next. So that will give me, and again, you can pay attention to the numbers to see if it's an upper bound or lower bound to help you out to figure out if you can cancel any. This didn't tell me nothing. So I'll try -1. So again, that's going to be 2, -1, -8, -5. So that's going to be -1 times 2 is -2, -3, +3, -5, +5. Ooh, there it is right there. So -1 is a 0. So that means that x plus 1 is a factor. And then I'm left with these guys, which again decrease by a degree. So this would be x squared plus x plus my constant. So clean it up, 2x squared minus 3x minus 5. Now I can factor this the normal way. So I'll try to factor this using the AC method so I can try to avoid the quadratic formula. This gives me -10, and then my b is -3. Two numbers that multiply to 10 but add up to 3. I'm thinking 2 and 5. And then if I make this a negative, perfect. So then I have x plus 2, x minus 5. And then we have to divide by the a. So this is going to be 2, this is going to be 2. So I get x plus 1. And then this will become 2x minus 5. But I think it wants you to write it as factored form. So before I go into this one, even though I'm not wrong, if you can't simplify the fraction, just leave it as 5, or that fraction itself, for this sake of argument. All right, so what other information do they want us to look for? The method to factor each of the following polynomials completely and then sketch the graph of each one. I'm going to stand corrected. And I'm going to write this. I don't agree with what that's saying. All right. So that's, again, bring the denominator to the front. It's going to be 2x minus 5. let's write it like this. It just makes more sense. All right, so therefore my function can be rewritten as x plus 1 squared, since I got the answer twice, times 2x minus 5. No, there's no specific order. I could have wrote 2x minus 5 first, then x plus 1 squared. I just went with this one because that's the first thing I saw. All right, then from that, it wanted us to sketch the graph so we can identify our information. So I know my degree, well, just looking at this, is going to be 3. And since it's a 2, I know it's going to be on and a positive. So I know it's going to look like this. My y-intercept is always going to be this guy right here. So in this case, I don't have to do any math. It's just going to be 0, -5. My x-intercepts are going to be these solutions that I got. So x equals -1 since I solved it here, but I could technically just take x plus 1, set equal to 0. Take 2x minus 5, set it equal to 0, and I would get x equals 5/2. So again, add 5 divided by 2. And then I got this answer twice, so well, just in case it wants you to write as a coordinate, -1, 0, 5/2, 0. This right here has a multiplicity. Again, it's not going to ask you all these questions, but it asks you random questions through it, and I just want to make sure you have all the different examples. This has a multiplicity of 2. This has a multiplicity of 1, so this bounces. This goes through. So when I come over here, I can sketch my graph. I got a y-intercept of -5. There's my -5 right there. Got one at -1. 5/2 is like 2.5. So about right there. And then I know it starts and stops like this. So I know I start here and I stop here. So this tells me I go to -1, I bounce, I jump down somewhere here, I go to 5.5, and I go through it. So roughly like this. Alrighty, let's do one more of those types so you have all the information. Let's do number 13. 13 says h of x equals x to the 4th minus x cubed minus 5x squared plus 3x plus 6. I cannot use the factor by grouping here because there's more than 4 terms. So I immediately know I need to use the synthetic division by finding possible zeros. All my factors of 6 is 1, 2, 3, and 6. All my factors of 1 is just 1. So I get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then you just kind of start the process of trying to figure out which ones could be the answer. So we start off with 1, and then that's going to be a 1, a -1, a -5, a 3, and a c. Remember, this represents x to the 4th, x to the 3rd, x to the 2nd, x, and my constant should be a 6. All right, then start the process. Drop down. 1 times 1 is 1. That gives me 0, 0, -5, -5, -2, -2, 4. Didn't work out. Let's try -1. So that's going to be 1, -1, -5, 3, 6. -1, -2, 2, -3, 3, 6, -6, 0. That worked out. So that means x plus 1 would be a factor. But unlike the previous example, this is still a cube. So that's this x cubed minus 2x squared minus 3x plus 6. So you have to repeat this process, but I've already used 1 and -1. So now I can use something like 2. So I'll use 2. And I'll do 1, -2, -3, 6. So use the new coefficients, because the goal is to get it down to a quadratic. You could technically do it here, but it'll just tell you it's a 0 and you won't be able to go further from there. So 2 times 1 is 2, 0, 0, -3. Ooh, heck yeah. And so that gives you 0. So that means that x minus 2 is a factor. This is now going to be my x squared, and this is going to be my constant. So this gives you x squared minus 3. Let me pause real quick. All right. All right, sorry about that. All right, so then what we're going to do here is now I'm just going to set this equal to 0. So this gives me x squared 3. I take the square root of that, so I get x equals plus or minus the square root of 3. So we're not going to forget that. So again, these are just possible zeros. It does not include all the zeros. So therefore, I'm not going to get the square root of 3 as one of those options. So now, if I needed to rewrite this, I would get h of x equals x plus 1, because that was one of them, x minus 2, because that was another one, then a plus or minus. So I'd have x plus the square root of 3, x minus the square root of 3. So this is what your answer will look like. And then, of course, if they wanted more information, I don't, some of them did and some of them didn't, but the leading coefficient or the degree, whatever is easier to write here, is all right here. So that's going to be which will be a positive even. So a positive even looks something like this. That is the degree. And then y-intercept would be next. Again, this is the y-intercept. So that's going to be 0, 6. X-intercepts, you have all the answers here. So that'd be -1, 0, 2, 0, negative square root of 3, 0, and the square root of 3, 0. So all this right here would give you these answers, and all of these have a multiplicity of 1. They all go through the x-axis. So if I had to sketch the graph as well, my y-intercept again at 6. So that's roughly right there. And then I have all these x-intercepts. So I have one at -1, +2, square root of 3. Oh gosh, that's got to be between 1 and 2. So here's 1, here's 2, roughly here. Roughly here. I really don't know, but between 1 and 2. Again, it's even, so I know it starts here, goes here. So all of them go through. So that means I go through at some point, come back up, go through this part, go through, come back up, and finishes here. I don't know how far down it goes, but being that close, I doubt it's that skinny. But there you go. So there's 13. All right, some other questions you could get. Let's look at number 17. 17 says use all available methods to solve each polynomial equation. So now 17, we just have to stick with just solving, no longer type of graphing. So let's take this x to the 5th plus 4x to the 4th plus x cubed equals 10x squared plus 4x minus 8. So what I got to do now is I'm going to set this equal to 0, and I'm going to put it in its like standard form as well. So I start off with x to the 5th plus 4x to the 4th plus x cubed. When I move x squared over, it becomes a minus 10x squared. When I move 4x over, it becomes a minus 4x. When I move a negative 8, it becomes a plus 8. And again, you can do it mathematically. If there's like terms, you need to combine those, but in this case, I do not. So therefore, I can go straight into solving. So p divided by q, all the factors of 8, divided by all the factors of 1. So 1, 2, 4, 8. And then this is just 1, so this gives you plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then kind of run the gauntlet. That's what I kind of with these type of problems here. So I'll try 1, and that would give me 1, 4, 1, negative 10, negative 4, and 8. So it gives me 1, 5, 6, negative 4, negative 8. Hey, first try. All right, so that's 1. Now remember though that this is still at x to the 4th. So x fourth, x cubed, x squared, x. So again, I'm going to try, I don't know, try the next one. I'll try 2. That's going to be 1, 5, 6, negative 4, negative 8. So this gives me 2, 7, 14, 20, 40. I can almost say this is not going to work. 36. Yeah, not going to work. All right, let's try negative 2. Then I'll go back to negative 1. That gives you 3, negative 6, 0, 0, negative 4, 8. Hey, that does work out. That gives me 0 right there. All right, so now what I still have an x cubed plus x squared plus 0x minus 4. So I really have x cubed plus 3x squared minus 4. Man, you can't factor that, but it sure would have been nice if we could have. So we got an answer of 1 and negative 2. Let's see. I'll try to do some quick math in my head. Because I still got negative 2 I could do. Oh, I just did that. I could do negative 1 and 4, 8. All right, to save ourselves some time, I already can kind of see negative 1's not going to work, and 4 and 8's not going to work. The numbers are going to get too big too fast for a positive or a negative. So because I got 2 answers already, I'm at an x cubed. And then we're just asked to use all available methods to solve each polynomial equation. So since those numbers don't work, what ends up happening is there's no more other zeros out of this, and I can't factor a cubic. So therefore, my only answers here are going to be x equals 1 and -2. Now, what you would have to do is actually do -1, 4, -4, +8, and -8, and then determine that none of those work. So therefore, these are your answers. For me, I'm just trying to save us time, so I'm not doing 5 different ways that's going to fail. So again, -1 would fail, 4 would fail, -4 would fail, 8 would fail, and -8 would also fail. And then I would come to the conclusion, all right, well, these are my only answers because I couldn't get to the point where I could factor. So that is only bad thing about these type of polynomial functions is you can do a whole bunch of work to find out that you had very little answers. Right. But that would be the process you would have to go through. And I'm just trying to give you some more examples before I run out of time. So this next one's number 20. So I have x cubed minus 9x squared equals 30 minus 28x. Again, I'll set this equal to 0. This gives me x cubed minus 9x squared plus 28x minus 30 equals 0. So then from there, my P over Q would be all my factors of 30 divided by 1. So it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, plus or minus 30. All right, so what I'll do is, again, just for sake of time, I'm going to plug in 3, 1, -9, 28, -30, 3, -6, -18, 10, 30, 0. Now, I didn't just know that. I happen to know what the answer is, but to kind of quickly go through it, again, I probably would have started the stages of 1, 2, 3, because there's really just no real way to figure that out, in my opinion. There's just guessing and seeing if that works. So it gives you x squared minus 6x plus 10. This is a quadratic, two numbers that would multiply to 10 but add to -6. -6. I can't think of anything because it's 2 and 5, 1 and 10. So therefore, maybe it's the quadratic formula. So that's going to be, again, A is 1, B is -6, C is 10. Quadratic formula, again, is -b plus or minus square root of b squared minus 4ac, all divided by 2a. So here we go. So that's going to be a -6 plus or minus the square root of -6 squared minus 4 times 1 times 10, all divided by 2 times 1. So here we go. Two negatives make a positive, so plus or minus 36 minus 40 over 2. This gives you 6 plus or minus -4 over 2. So this gives you 6 plus or minus 2i, because remember the negative comes out as an I, square root of 4 is 2. And then I'm separating this as 6 over 2 plus or minus 2i over 2. So that gives me -3 plus or minus I. So there's my answers. I got 3, and then it looks like 3, that should be a positive. 3 plus or minus I. All right. So let me do another type of question. I feel like I'm running out of time. Let's look at 25. It says use all available methods, in particular the conjugate root theorem, if applicable, to factor each of the following polynomials completely, making sure to use of the given 0 is one of the given, right? So basically it wants us to give the answer in factored form. So if I have this right here, this makes life a little bit easier. So I get x minus x to the fourth minus 9x cubed plus 27x squared minus 15x minus 52. And it tells me that 3 minus 2i is a 0. And using the conjugate root theorem, if 3 minus 2i is a 0, then I know 3 plus 2i is a 0. So what we do is we did 3 minus 2i in the window, and we can kind of go a lot quicker because we have answers now. We just got to go find the rest of the answers. So that gives me 3 minus 2i. That would give me negative 6 minus 2i. Now I got to pull this out. So that would give me negative 18, negative 6i, positive 12i, positive 4i squared. So this right here would turn into a negative 4. So this would give me negative 22 plus 6i. That would then give me 5 plus 6i. And then I would need to do that again. All right, so then that would give me 15, 18i, negative 10i, negative 12i squared, which will turn into a positive 12, which will then give me 27 plus 8i, which is 12 plus 8i. So then I do this all again. So give me 36, 24i, negative 24i, negative 16i squared, which will turn into a positive 16. So that's going to give me, what is that, 40, 52. And then those will go away. So 52. And then that gives me 0, which makes sense, right? Now, this is still a cubic. So then I would have to use this next one here. So then I'd do 3 plus 2i. And it would now be using these new values. So 1, negative 6 minus 2i, 5 plus 6i, and 12 plus 8i. And I should get 0 again. That'd definitely be a check to make sure you do get 0. If you don't, you've done something wrong because we were already told that these are zeros. All right, so the two i's would cancel. This would just give me negative 3. Then when I distribute that, that would give me negative 9 minus 6i. That would cancel, giving me, what's that, negative 4. And then gives me negative 12 minus 8i, which would cancel. Oh, that was real quick and easy. All right, this is now a quadratic. So this is now x squared minus 3x minus 4. Started with a fourth, went down to a third. Now it's a second. So then I can try to factor the rest of this, and this would be multiply to 4, add to negative 3, that's going to be 1, 4, negative. So that gives me x plus 1, x minus 4. And then you can add in your other answers. And I believe that's what they want you to do on 25 is write it in that form. So you would write it as x minus 3 minus 2i. I did not give myself enough room. So I'll write it on this side. X minus 3 plus 2i. So to simplify this up, this will give you x minus 3 plus 2i, because all I did was distribute. And then do the same thing over here, and I get x minus 3 minus 2i, and then rewrite x plus 1, x minus 4. So this is what it's looking for. All right, let's do another one to make sure we fully understand. We'll look at number 28. 28 says p of x equals x to the fourth minus 2x cubed plus 14x squared minus 8x plus 40. And it tells us 2i is a 0. And if 2i is a 0, then the conjugate of that is actually negative 2i. So I know both of those are zeros. So 2i is a 0. We'll start there. Hopefully it won't be as bad as the previous one. So the 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. Make sure I got all my coefficients. That gives me 2i. It will be. So this is negative, well, not so bad. So this is negative 2 plus 2i. Distribute this out. This will give you negative 4i, and this will give you positive 4i squared, which would be negative 4. This will then give you 10 minus 4i. This will then give you 20i, and then this will give you negative 8i squared, which is a positive 8. And then that right there would cancel. So then I just have 20i. And then that would give you 40i squared, which is actually negative 40, which will give you the 0 that we were looking for. And then I know negative 2i is a 0. So that's going to be 1, negative 2 plus 2i, 10 minus 4i, and 20i. Negative 2i gives you negative 2. That's going to be a positive 4i, which is 10. And then that gives you negative 20i, which is 0. Again, this is my quadratic. So this is x squared minus 2x plus 10. Two things that multiply to 10 but add up to 5. My bad. Two things that multiply to 10 add up to negative 2 is, ooh, 2 and 5 is the only way I know how to get to 10. I don't know how to make that to get to 3. All right, so what we're going to have to do is not be able to factor and have to use the quadratic formula. So that's going to be negative b, so that's going to be a positive 2, b squared minus 4 times a times c, 2 times 1. So 2 plus or minus 4 minus 4d, 2 plus or minus square root of negative 36 over 2, 2 plus or minus 6i over 2, which will give me 1 plus or minus 3i. So I end up with 4 different complex numbers. So I got plus or minus 2i. Oh, I guess I'm looking for this in factored form. So let me write this in factored form. So this will be x minus 2i, x plus 2i, x minus 1 plus 3i, and x minus 1 minus 3i. Distribute that negative, and I get x minus 1 minus 3i, x minus 1 plus 3i. So there's your answer there. All right, let's just do one more before I do the last type of question. So this is number 36. So it says g of x equals x to the 6th minus x to the 4th minus 16x squared plus 16. So I told you before there is a way to solve this using factor by grouping. So I'm going to group up the first two, group up the last two. So these have an x4 in common. I'm left with x squared minus 1. These have a 16 in common, but since the leading term is a negative, I'm going to put a negative 16, which gives me x squared minus 1. If these are the same, I can write it down once, and then I can write these out. So x to the 4th minus 16. These are a difference of squares. This is going to be x minus 1, x plus 1. This is going to be x squared minus 4, x squared plus 4. On this one here, I know it can't go any further, but is it okay? No, we gotta leave it that way. Okay, so then this would be x minus 1, x plus 1. This is another difference of squares, so x minus 2, x plus 2. This cannot break down, so what I have to do is I have to go solve it. So this is going to be x squared plus 4 equals 0. So x squared equals negative 4. Take the square root. I get x equals plus or minus 2i. So then it becomes x plus 2i and x minus 2i. So then this is how you would do it without being given any zeros. So this is again factor by grouping. Group up the first two, group up the last two, find the GCF. If they're the same thing, write it down once, write out the factors that come down from it, and then keep doing the perfect squares, which again, basically just take the square root of each and then write down the result. And you can write it here. And then you just keep going until you can't. I can't do that because I don't have a sum of squares, I only have a difference of squares. All right, so I know that was kind of quick, but I want to go over the last type of questions you'll see. So let's look at number 37. This one you have to construct it. So just like in the previous example, you're given a third degree, or in the previous lesson, third degree, only real coefficients, and I have zeros of -1 and 5 plus I are two of the zeros. And so if 5 plus I is a 0, then you know 5 minus I is a 0. Now you have all three answers because I told y'all the fundamental theorem of algebra means that I'll have at most the degree of answers, even if they repeat. So here we go. So then I'll write it in factor form. So x change basically the sign. So it's minus all these results. So it's going to be plus 1, x minus 5 minus I, x minus 5 plus I. Now, I think it wants you to write it in standard form, and it does. So then we'll just distribute it out. Probably starting with this right here. So this gives you x plus 1. I know I'm going fast, but I don't want to run out of time. So x squared negative 5x plus 5I negative 5x positive 25 negative 5I negative ix positive 5I negative I squared. Clean it up. I believe 5 i's would cancel. So that would give me x squared negative 5. Oh, this would be xi. So this would be xi or ix. Those would cancel. And then make sure I got the rest of this. And this 5i will cancel with that one. All right, so usually that's what happens. This will become a plus 1. So now I get x squared minus 10x plus 26, because that's what 25 plus 1 is, and then times x plus 1. So then we work it out again. So this is going to be x cubed minus 10x squared plus 26x plus x squared minus 10x plus 26. So x cubed minus 9x squared plus 16x plus 26. And then it said, and the y-intercept is 52, or yeah, negative 52. So what to do to multiply 26 to get to negative 52? Multiplied by negative 2. So I get negative 2x cubed, positive 18x squared, negative 32x minus 52. And there you go. So that's how you would do it. And I want to do one more so you have plenty of examples. And again, if you need me to do some more or go slower or whatever, just let me know. So we got a fifth degree, 1, 0 with a multiplicity of 3. So that means I have only two more answers, and it says in negative 2 is the only other answer. So that means there has to be 2 because this has to add up to 5. And then it says the leading coefficient is 2. So that means I have x minus 1 because we changed the sign to the third power, x plus 2 because it goes from 0 to a factor. We change the sign to the second power. So therefore, this is going to become all right, so here we go. So this right here will just be x squared minus 2x plus 1. This right here would just be x squared plus 4x plus 4. Then distribute this one. This is going to be x cubed minus 2x squared plus x, negative x squared plus 2x minus 1. then that will be left with x cubed minus 3x squared plus 3x minus 1. And then do it one more time. I don't know which way would be quicker. So x to the 5th plus 4x to the 4th plus 4x cubed minus 3x to the 4th minus 12x cubed minus 12x squared. And now I'm on this one. So then 3x cubed plus 12x squared plus 12x. Now I'm on the last one. So that's going to be negative x squared minus 4x minus 4. Okay, so x to the 5th by itself goes away. I got 4, 3. That's going to be a positive x to the 4th. I have 4. That would be a negative 8, a negative 5. I have 12. That would cancel out. I have 12 minus 1, so that's 11. Nope, I almost lost it. So that's actually negative x squared. 12 minus 4 is 8. Minus 4. And then, of course, the last thing it says is leading coefficient is 2. Take that whole thing, multiply by 2. And there you go. So it can be tedious, it can be a lot of work, but I find it to be fun when we get to the end. So that's all I have for this section. I'll see you in the next video.